you guys. I am ready to start Module 16, Lesson 1. So I hope everything went well yesterday with the Module 15 practice test. Yeah, I hope it went well, and I hope you guys already did the Are You Ready quiz on page 420. Just a couple questions about fractions. Module 16 is, we're just continuing fractions. And so I'm excited for this module. It's another really short one. So many short modules lately. I don't know what's going on, but that's okay. So this one is on representing equivalent fractions with smaller parts. So this is super exciting. Equivalent fractions, this is super cool, gonna blow your mind. And a lot of our, well, of course we need our fraction skills, what we know about fractions and equal parts and naming parts, numbers of parts, and also multiplication. So we've done a lot with multiplication this year. You guys know your math facts, your multiplication facts, and so you can start recognizing these patterns and recognizing the connection between multiplication and fractions, and then eventually multiplication, division, and fractions. So I'm super excited. So I'm on page 421. The I can statement says I can represent a fraction with equal parts that are smaller in size than the equal parts of an equivalent fraction. Sorry, I read that kind of funky, so I'm gonna read it again. I can represent a fraction with equal parts that are similar in size than the equal parts of an equivalent fraction. Basically, we could say we can show two fractions that are similar in size, even though the fractions are different numbers. Okay, so let's get this started. The Spark Your Learning says, Kyra folds a sheet of paper in half and shades one of the two sections. Julio folds Kyra's sheet in half again. Kyra says 1/2 of the sheet is shaded. Julio says 2/4 of the sheet is shaded. Who is correct? So for this activity, I forgot to grab a paper. I'll just do this printed paper. Okay, so it says Kyra folds a sheet of paper in half, so that's what I'm gonna do. Okay, so here I folded it in half. Okay, and then she colors one part of the paper, 1/2 of the paper. So I'm just gonna shade it really fast. And you guys try this out too. Grab a piece of paper. Sorry I didn't do this at the beginning. Grab a piece of paper, fold it in half, shade one of the parts. I forgot that I was gonna do this, so my coloring is going very slow. Okay. Okay. So now you guys have your paper. I have my paper. Here we have one part of it shaded. So this is Kaya's fold. And then Julio comes in and folds it again. So I'm gonna fold it in half again. And then I'm gonna open it back up. Okay, so now I have 1, 2, 3, 4 equal parts. 2 of them are shaded. So who is right? Is it 1/2 of the paper or is it 2/4 of the paper? They're the same. So that is what is so cool. That's in half. And that makes sense, right? Because half, that's over 2, half again, that's over 2 again. 2 times 2 is 4, so now I have 4 equal parts. And now instead of one part being shaded, 2 parts are shaded, but those parts became smaller, right? Because my denominator changed, my numerator changed. because the number of parts changed. But this side was still colored, right? This was all colored. Ah, so cool. So it's the same. Julio and Kyra are both correct. So on our Spark Your Learning, if we were to draw out what we just did, we folded that paper in half like that, colored in one of the parts, and this was 1/2. Okay, then we took that same fold, so I'm gonna copy exactly what I did here, shade it in again, and then we folded it in half again like this the other way. So now I have 1, 2, 3, 4 parts, and now 2 of them are shaded. So see how the same shape, the same space was shaded, but we're just using different fractions to represent that same space. So before, when we had the one fold, we had 2 parts, denominator is 2, 1 part is shaded, numerator is 1. But then we came in, this was already shaded, we folded it again. Now we have 1, 2, 3, 4 parts, so the denominator is 4, and then 2 parts. So those 2 small parts equals 1 of this bigger part. So cool. So we could say that 2/4 is the same as 1/2. Pretty cool. You guys will start noticing more and more patterns. Let's see. We already answered the turn and tuck. It says, what fraction is now shaded? We said 2/4. Okay, so next page on the Build Understanding. It says, Tia folds a square sheet of paper in 2/4. She shades 3/4 of the paper red. Show how Tia's paper might look in the workspace on the left. So here's my workspace. I'm using the one on the left. She folded it into 4ths. So she folded it in half and then in half again. Would probably be the easiest way to fold it, but there's other ways to fold it as well. And then she shades 3/4 of the paper red. So that's 3 parts that are red. Like that, okay? Then the next direction says, Tia takes the folded sheet of paper and folds it again to make 8s. Show how Tia's paper might look now in the workspace above on the right. So I am going to draw my 4ths first, because that stays the same. Draw my 4ths, color in 3 of them. Okay, now I'm going to divide this in half. So the top in half and the bottom in half. And that created 8. 1, 2, 3, 4, 5, 6, 7, 8. 8 equal parts. So now the parts are smaller, but the same area is shaded. So let's answer these questions. What fraction of the paper is now shaded red? Now we have 8 equal parts, so that goes on the bottom. And how many are shaded? 1, 2, 3, 4, 5, 6 parts are shaded. How does 3/4 compare to the fraction Tia made by folding the paper into 8ths? So 3/4 and 6/8, what we just got, those represent the same space. These are equivalent fractions. So you would say they are the same, or they are equivalent. The turn and tuck says, what happens to the size and number of the equal parts each time Tia folds the paper? Well, every time you fold the paper, you're creating more parts. Those parts are becoming smaller, but now there are more of them. Pretty cool. Okay, I know I keep saying that, but it's just so cool. Number 2 says, on the next page, page 423, Alvin folds a strip of paper into thirds and shades 2/3. Then Alvin folds the same strip again into 6. Show Alvin's strip folded into thirds and 6. So I'm going to do the first one into thirds. And be as careful as I can and shade 2 of them. Then he folds it into 6. So now, as I'm redrawing it, I am going to use the same lines that I did for the thirds, right? So that I can look at it and it's the same. And then what am I going to do to make 6? Well, I already have 3. What number will get me from 3 to 6? 3 times 2. So I'm going to split each of these in half. Now I have 2, 4, 6. 2 times 3 is 6. And then I'm going to shade the same space. So remember how this was my 2/3. So I'm going to stop at that same line. Okay, there we go. So now I have 2/3. And then this one is going to be 6 because there's 6 equal parts. And how many are shaded? 1, 2, 3, 4. Oh, okay. So then part A says, divide the number line to show thirds and 6. Label the fractions on the number line. Then draw a point to show the part of the strip Alvin shaded. So it already did the number line into thirds. 1/3, 2/3, 3/3. So I'm going to label that 1/3, 2/3. So then what did I do to the fraction strip to make 6? I took my thirds and I cut them in half. So I'm going to do the same thing on my number line. 0/3 to 1/3, cut it in half. Now I have 0/6 and 1/6 and 2/6. See that? So then I'm going to do the same thing from 1/3 to 2/3, cut it in half. Now I have 3/6 and 4/6. Okay. Split that in half. Now I have 5/6 and then finally 6/6. So see how I'm counting by thirds on the bottom, counting by 6 on the top. And then you can see where they match. Those must be equivalent fractions. So that's our vocabulary. Equivalent fractions, it says 2 or more fractions that name the same amount or distance on a number line are called equivalent fractions. So we know we can use fractions to represent like amount, like on the number strips, or distance, like on the number line or a ruler. So then it says, what fraction in 6 is equivalent to 2/3? How do you know that the two fractions are equivalent? We already did that because we're superstar students. It is 4/6 is the same as 2/3. So now we'll just answer why. Or how? How do you know that the two fractions are equivalent? Well, we know because we drew our thirds exactly the same, split it in half to make 6ths, and counted those equal parts, shaded the same area. And we also know by the number line. If we look at our number line, 2/3 and 4/6 represent the same spot on the number line. Or they're at the same spot in the number line. Very cool. So the turn and talk says, can two fractions with a different number of equal parts be equivalent? Explain. So what do you think? Can two fractions with a different number of equal parts be equivalent? What do you think? It took me a while. I was like thinking about it. Yeah, of course. Because the number of equal parts is the denominator, and we just proved that 2/3 and 4/6, those have different denominators, but they could still represent the same amount. It just depends on the numerator and how many parts you have. Pretty cool. Okay, so now at this point, I'm mixing it up a little bit. So normally in class, when we're at this point in the lesson, you guys will do the check understanding by yourself. And then me or Miss Shields would come give you a stamp if you did it. And once you got a stamp, you got to go to the on your own and work on that paper by yourself. So to make it feel a little bit more like you are doing this on your own, exploring it on your own, and you might already be doing this because you're Superstar students. It's okay if you're not already doing it, but I want you to just challenge yourself. So I want you to pause the video and do the check understanding by yourself and do the on your own by yourself, and then play the video and see if you got it right. Does that make sense? So you're kind of doing this by yourself, but then I'm still here to check it off for you. So pause it and be right back. Okay, so let's check the check understanding. Number 1 says, shade to show 1/4, then draw a line to show an equivalent fraction. So I'm going to take this. It already did 4 pieces for me. That was so nice. I'm going to shade one of them. Okay, and that's going to be 1/4. Then I'm going to draw a line just in half right here to make a new fraction. So basically this is like another fold on the paper. So now how many pieces do I have? How many equal parts? 1, 2, 3, 4, 5, 6, 7, 8. And I could have guessed 8 because I had 4. I split it in half. 4 times 2 is 8. There we go. Are we noticing a pattern? So now my 1/4 became 1/2/8. So that's my equivalent fraction. Number 2, draw a point to show 1/2, then write the equivalent fraction. So it already labeled it for me, so nice. I'm going to find 1/2, draw a point, and then the equivalent fraction would be on that same point. So I'm just going to go right above, and the fraction right above is 3/6. So I'm going to write 3/6. Those are my equivalent fractions. Awesome, awesome. Last page on your own. Number 3, Brian shades 1/3 of a circle green. Show an equivalent fraction on the same sized circle. That's important, the same size. It's always important that they're the same size. Okay, so write the equivalent fraction. I have Brian's circle and your circle. Now before I even draw any lines or anything, I'm going to make the same shading. Okay, so he shaded 1/3. I'm going to shade 1/3 right now, just so that I know that I'm using the same amount of space. I can be certain. Okay, so now to do an equivalent fraction, the easiest thing I think is to just take the pieces and cut them in half, no matter what it is. Triangle, rectangle, circle, take it, cut it in half. So with the thirds, I'm going to go from the center, because if we have like circular shapes, we go from the center. That's going to be the easiest. And I am just doing another Y shape to cut each of the thirds in half. See how I did that? So now I have 1, 2, 3, 4, 5, 6 pieces, and that makes sense because 3 times 2 is 6. So now I have 6 equal pieces, so that's going to be my denominator. Now how many pieces are shaded now? It's the same space, and I know it's the same space because I shaded it before I even cut the fractions. So now I just have to look and see how many parts I have now. 1, 2. So 2/6 is shaded, and that is equivalent to 1/3. Explain why the fractions shown by Brian's circle and your circle are equivalent. So you would write out what you thought. They are equivalent because they are the same size circle. I shaded the same amount. I just cut that amount in half and use different fractions to represent the same amount of space. So that's how you know they're equivalent. All right, number 4, locate and draw a point on the number line for the fraction. Then write the equivalent fraction in the equation and on the number line. So number 4 is 2/4. So I'm gonna find 2/4, put a dot. Now I'm noticing these lines right away that don't have any labels on them, but I see on top the number 8, 0/8 and 8/8. So that tells me that I'm counting by fourths on the bottom, eighths on top. So this would be 1/8 here, 2/8 next, which is the same as 1/4 because they're on the same line on the number line, 3/8, 4/8, 5/8, 6/8, 7/8, and then 8/8 is typed out for me. So then I'm gonna look, okay, here's 2/4. 2/4 is the same as 4/8. Da-da-da. Number 5, 2/3 is equal to, so I'm gonna do the same thing where I find 2/3 on my number line. There it is. Put a dot. And then I'm gonna count by 6 on the top. And I know I'm gonna count by 6 because that's what it says. So I'm just gonna count on. 1/6, whoops, 2/6, which is the same as 1/3, because they're on the same line, 3/6, 4/6, 5/6, and then finally 6/6. So 2/3 is on the same spot as 4/6. So 2/3 is equal to 4/6. Number 6. Explain why 3/3 equals 4/4 for the same size whole. Draw to justify your answer. Okay, this is a really cool one. 3/3 equals 4/4. I am going to cut my rectangle into thirds. That wasn't very even. I kind of did it sideways, but that's okay. So the denominator is 3, so that tells me how many parts there are in the whole. The numerator is 3, so that's how many parts I'm going to shade. That's how many parts I'm counting. 1, 2, 3. It's the whole thing. So it's just one whole. Then I'll do the same thing for the fourths. Cut it into 4 equal parts, like that, and then I'm counting 4 of them. 1, 2, 3, 4. That is also the whole rectangle. So they both equal one whole rectangle. So that's what you would write down. 3/3 equals 4/4 because they both represent the whole rectangle. They represent 1. Just equals 1. Okay, awesome. I hope that went well for you. I hope you're feeling confident about it. If not, that's okay. Just keep practicing. Good luck on your homework. And let me know if you need anything. Bye. Love your guts.